All right, so here we go with exponential functions. And just as a fair warning, there's going to be a lot of graphing. So if you don't have graph paper, you need to go out and get some. So we need to start off by defining what an exponential function is. So an exponential function is in the form of f of x equals a raised to the x, where a has to be a positive number, and we're not going to have it equal to 1, because 1 raised to anything is still just going to be 1, so that wouldn't be interesting. And we're also going to define that x has to be a real number, so no imaginary numbers. So what we're going to do for right now is we're just going to focus on what do the graphs of exponential functions look like. So let's start with the most basic graph that we can come up with, which would be 2 raised to the x power. So for right now, you have no idea what this is supposed to look like, so let's just make an x and y table. So let's plug in 0 for x, and when we do that, 2 raised to the 0, anything raised to the 0 is 1. So I'm going to go ahead and plot that point right here. Okay. Next, let's plug in 1. 1, so we have 2 raised to the 1, that gives us 2. So if we go over 1 and up 2, we get our next point. All right, let's keep going. We have 2 for x, so 2 raised to the 2 power is going to give us 4. And so going over 2, up 1, 2, 3, 4. And so right now you're kind of feeling like, oh, this looks kind of like a parabola, right? 1, 1, 2, 4. But unfortunately, it does not continue to follow that pattern. So if we plug in 3, we're going to get 2 raised to the 8th power, or 2 raised to the 3rd power, which is going to give us 8, right? Okay, let's fill that in. And then when we plot that, let's see, we're going over 3, and 1, 2, 3, 4, 5, 6, 7, 8. I'm all the way off of my paper there. Okay, so here's where it starts getting interesting, because now when we start plugging in negative numbers, say a negative 1/2, that's 2 raised to the negative 1, which if you recall, that's going to be the reciprocal. So that's going to give us 1/2. I'm going to have to move to a smaller little dot here in order to show that. So that's going to be right here, or somewhere thereabouts if it were on the line, if I were accurate. Okay, and so if we keep going, let's see if we have a negative 2. So now 2 raised to the negative 2 power is going to be a positive 1/4. So once again, little tiny dot, we're down here. Oops, let's get on the line. Yeah, close enough. Okay, so you can kind of get the feel for this is that as we're getting closer and closer to negative infinity, this is just getting closer and closer to 0. So if I were to try, and don't laugh, this is going to be terrible when I go to connect them. Ooh, that was better than the first attempt. Okay, so there we go. And this is going to keep going like this. My question to you is, do you think it's ever going to, the curve ever going to cross over the x-axis and go down here into negative numbers? And hopefully you're thinking, no, it's not going to ever do that. So what we end up getting is this asymptote, which, if you recall, is a line that your graph is going to approach and get closer and closer to, but it's never going to cross over. So all of our exponential functions, when we graph them, are going to have an asymptote. And the exponential functions, their asymptotes are always going to be horizontal. They're not always going to be on the x-axis, but they are always going to be horizontal. Okay? So let's try another one. Oh, we already defined what an asymptote is, so. All right, so here we go. Now we have something a little bit more complicated, only in that our exponent is x plus 1. So we're going to go ahead and just do an x and y t-chart like we did before, but I want you to also start thinking about all of our translations that we did with parabolas, and how some parabolas got shifted left and right, and some parabolas got shifted up and down, and where we saw those shifts within the equation. And if you might recall that when we had something added or subtracted to the x, that was a left and right shift, and it was actually in the opposite direction from the sign. So while we work out our table, you're going to kind of see that shift occurring. Eventually, I hope that you can do these without having to make tables, and you can just look at the translations, but if you never get there, that's okay too. Okay, so the first one, you plug in 0, that's going to give us 3 to the 1 power, so that's going to give us 3. So at 0, I'm going up 1, 2, 3, right there. Okay, so next one, we plug in 1, so now this is 1 plus 1 is 2, so 3 squared is going to give us 9, and I think I'm going to be off my graph at that point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we'll say this green line is at 9. Okay, so pretty much that's as far as I'm going to be able to go on my graph. So let's start going in the negative direction. So negative 1. So negative 1 plus 1, that's going to be 0. 3 raised to the 0, that should give us 1. So negative 1 was up at 1. Okay. And let's keep going. We have a negative 2. That's going to give us the 1/3. I'm going to go for my little dot now. So we're only up at a third, which is right there. And just for fun, do I have another one? I don't think I do. You can imagine if I had negative 3 here, that it would be down here at negative, or at 1/9. So if I went ahead and, tried to draw in my curve. Whoa, missed that one, sorry. Okay, so there we go. There's our curve. You can see how this is still going to approach the x-axis. So the x-axis is going to be our asymptote once again. Okay, so if you think back to the previous graph, and maybe you have this graphed on some paper because you're taking notes, like good little students, this point, there's always going to be a point where the exponent is 0. So you have your base raised to 0, it's going to equal 1. And you can see that in the previous graph, it was over here when x was 0. But now that we have x plus 1, we got that point shifted 1 unit to the left. So if you remember how I said the opposite direction from the sign, we have a plus 1, so we shifted to the left 1. So everything got shifted to the left 1. Okay, so there's that point that used to be over here. So just kind of keep that in the back of your head. We're going to do another example here. Oops. Hit that button. There we go. Moving on. All right, so we're going to look at this one. Now we have two different things going on. We have our exponent is negative, and we have a minus 3 out here. So what I would like to do, first of all, is recall what the negative exponent means. That means the reciprocal. And I'm also going to ignore the negative 3 or the minus 3 out here, because I know that that's going to be a translation. So I want to show you how you can do this as a translation. So if we just look at f of x equals 2 raised to the negative x, which is 1 over 2 to the x, we can go ahead and fill out our table 0, 1. So 0 up 1, there was that typical 0, 1 coordinate. Okay, we do 1 and we should get 1/2 because we're plugging in the 1 here. So now, little dot, at 1 we're at 1/2. So now that's over on the right hand side if you notice. Okay, next one, if we did 2 we get 1/4. So that's going to be down here. So it looks like we're still going to be approaching an asymptote. Okay, so now let's try our negative 1 exponent. So if this is a negative 1, that's going to move this back up here to become 2. So at negative 1, I'm all the way up at 2. Okay, and you can imagine at negative 2, I'm going to be up at 4, and so on and so forth. Okay, so awesome. We can see how this curve is going to keep going like this, traditionally, right, and approach the x-axis. That is just this curve right here. But now, this minus 3 means that this entire curve is going to get shifted down 3 units. So I'm going to now use my red dots, and each point here is going to get shifted down 3 units. So this one's going to go 1, 2, 3. This one's going to go 1, 2, 3. This one's 1, 2, 3. We'll get my little dot here. So this one's going to go 1, 2, 3 right here, and then this one's going to go there. So this whole curve got shifted down 3 units. Let's see if I can draw this backwards. Wish me luck. Oh dear, oh dear, oh dear, oh dear. Ah, I did it. Okay, Good enough. All right, so there's my curve. Now, let's think about this. Where is your asymptote? Hopefully you guys see that your asymptote is going to end up being down here at -3. Okay, so I really would like you to try to graph these using our skills from translating graphs in parabolas, because it follows the same thing. If you add or subtract something outside of this exponential, that's a shift up or down, and it's a direct shift, positive, negative. And if you have something in the exponent, that's going to shift you left and right, and that's the opposite direction. Okay, this is getting to be a long video. I apologize. All right, so the last thing that we need to talk about is the natural base, which we represent with the letter E. And E is another irrational number. It's like pi. It's a non-repeating, non-terminating decimal. So if you have a scientific calculator, you should look for the button that says e to the x. And if you want to try it out, take e and raise it to the 1 power, and you should get this decimal. And depending on your calculator how far it takes it, it may look like it keeps repeating, but it doesn't. If you really, really had a computer that showed you all the numbers, it doesn't repeat. Okay, so if you are asked to graph an exponential function with the base e, it's the same process that we did before. So if you plug in the numbers, obviously e to the 0 is going to be 1. E to the 1 is going to be that 2.718. E squared is going to be 7.389. E to the -1 is just 1 over e, so that's 0.368. So I can go through and I can actually graph these, right? 0, 1, there's our typical. It's like the vertex of exponentials. 1 is at 2.78, so I'm going to go somewhere in the middle there. 2 is at 7.3. 1, 2, 3, 4, 5, 6, 7.3. We'll just say for there. And then the -1 is going to be at 0.3, so somewhere around here. So you can still see that it follows the same shape as all the rest of our exponentials that we have. It's still going to have an asymptote, just like normal, okay? And our asymptote is there at the x-axis. All right, so your job for today, or when you end up going to class and getting the worksheet, is going to be to graph a whole bunch of exponential functions. So I hope you bring graph paper. If not, you're going to have to borrow from a friend or wait until you get home and buy some new stuff. Okay, good luck. I hope that was okay.